we're going to look at the relationship between permutation and combination. Okay. In the earlier video, we have looked at this, and we have look at MPR and NCR. Okay. Now see how is the relationship between both of them. Now NCR is equal to n factorial over n minus r factorial times 1 over r factorial. Okay. Now then this part here actually is NPR. So I'm going to replace it with this part here of NCR. I'm going to replace with NPR. Okay. So NCR is equal to NPR times 1 over r factorial. Okay. Now let's look at an example, and it will be clearer. If you look at this, go through this example. Now, consider we have three letters A, B, C. I'm going to select 3P2 means I'm going to select 2 and arrange them in a row. So 3 is 3 alphabet A, B, C. 2 is going to select 2. So this is how we're going to arrange it. AB, BA, BC, CB, AC, CA. So in terms of arrangement, all of them are none of them are exactly the same. I mean, they are all different. So there are actually 6 ways of arranging. So 3P2 is actually total 6 ways. Now, what about combination? 3C2. The selection is still the same. AB, BA, BC, CB, AC, CA. Okay, these are all the possible combination that you can obtain if you select 2 from 3. But in terms of combination, if you get A first, B second, or B first, A second. Okay, there's no arrangement. You just select them. Select A and B and B and A. In terms of final answer, you still get AB. A BA, you still get AB. Okay, AB is AB. So, in the combination, this is actually one combination. Okay, one way only. Similarly, BC, CB is one combination, one way only. So, you talk about C3C2, total different combination is only 3. Okay, because no arrangement is required. AB and BA is the same answer. So you can see here 3P2, 3C2, using what we see here, 3C2 equal to NPR, 3P2, okay, is equal to 2 factorial, times 1 over 2 factorial. You can see that 6 times 2 factorial is 3 here, is 3. Okay, what are the key things we learn from here is, first of all, combination always have less number. Okay, why? Because you're not going to arrange them. If the selected one is the same like AB and BA, they are the same. Only the sequence of when they are selected doesn't matter because there's no arrangement. So it will be less. Okay. So now, how do you tie this and this together? You can see that is actually NCR equal to NPR and divided by R factorial. Okay, you're going to select 2, then this becomes 2 factorial. Okay, so if you have, let's say, I'm going to select 3 out of 4. Okay, then it becomes 4 C3. Okay, and then you got 4B3 times 103 factorial. Okay, So this is how you use it uh, to to understand why there's a need to divide by 3 factorial. Okay. Uh, so that's it. Now we're going to use this concept on the combination. Uh, before we proceed, if you look at the earlier video, you actually to calculate NCR, you don't use this method to calculate. You can use what I taught you in the earlier video. Okay. This one is just to show you that the NCR is actually less than MPR, and to what degree, basically you divide by R factorial. That will give you NCR. Okay. Now we're going to look at this term here, not distinct. What's the meaning? Not distinct basically means, you see, whatever we have covered earlier is all the alphabet, all the letters are not the same. They are very distinct. For example, I have 6 wasps. I'm going to pick 4 out of the 6 wasps and arrange them. In all these examples, the 6 wasps, the flower wasps, are not the same. Okay? So, whatever we learned earlier are all based on distinct, the items are all distinct. They are not the same at all. Okay, each of them not the same. But now there are questions whereby it could be 1 or 2 the same. Now let's look at one example here. Let's take the word success, SUCCES is 1, 2, 3, is 1, 2, is 1, 1. The alphabet below the letter is to tell this, they are actually the same. S1, S2, S3, they are the same. They are exactly, in terms of appearance, they are exactly the same. But this is just to show you in the process of explanation, this putting 1, 2, 3 will be helpful. Okay? Now, so if I take 1, 2, 3, 4, 5, 6, 7, these 7 letters, I'm going to arrange them. How many ways can I arrange them? Okay, bear in mind, if I have S2, U1, C1, C2, E1, S1, S3, okay? There's no difference between these S2, S1, S3. So if you compare these, they are considered one way only. Okay? They are considered one way only. You can have many more. Basically, it's like as though you are arranging how many of these arrangements where they are actually the same. Basically, it's very simple. You see, you got S1, S2, S3. How many ways can you arrange this? It's basically this 3 times 2 times 1. Okay? So there are actually 6 ways. If these letters are different, okay? Since it's the same, all this is the same. It's considered one way only. So if you work on this, there are 6 arrangements where they are exactly the same. Okay, 6 arrangements where they look exactly the same. So in terms of the arrangement, there's only one. All these 6 where you swap them S2, S1, S3, or S3. They actually, this arrangement is actually one arrangement only. Okay. Now, this actually also 3 factorial equal to 6. What about C1, C2? C1, C2 basically is to fill up this space is you can have a two choice, either C1 and C2. So it's 2 times 1. If you have 2, which can be written as 2 factorial. Okay, there are C1, C2, one way, C2, C1, two way. But all this is considered one arrangement because they are identical. Okay. Now, so using this same principle, D is for combination A, B, B is the same. So you got 2 factorial. Now, so the number of way of arranging this would be number of way will be equal to 1, 2, 3, 4, 5, 6, 7. Will be 7 factorial over. There is 3 factorial here. 1, 2, 3. So it's 3 factorial. What about this? This is actually 2 times 1 times 2 factorial. Now, the U and the E, there's only 1. So it's got 1 factorial times E also 1. Letter is 1 factorial. Okay? So, this is the number of way of arranging this word success, whereby you have 3 similar S letter and 2 similar C letter. These 3 factorial represent the S1, S2, S3. The C2 factorial represent the C1 and C2. U1 will be 1 factorial, E1 will be 1 factorial. Okay, so this is the answer. This is a way when the letters are not distinct. Okay, so that's it. Hopefully you understand fully what is